We want to now prove DeMoivres Theorem, and the proof we're required to do by the syllabus is to do it by induction. Now, if we remember what DeMoivres Theorem was, we're going to take modulus to be 1 in this case. So it just makes life a little bit easier. So this is what we need to prove. To do this, what we want to do is remember our two of our results from the Extension 1 course with sine of a plus b and cos of a plus b. So remember those in our proof. So doing our proof by induction is just as normal. So we test for n is equal to 0. And we see that our left-hand side is equal to our right-hand side. That's all 1. That would be 1. And that's 0. So it all works out nicely. So our second step, as normal, would be assume n is equal to k. And assume it's true. So cos theta plus I sine theta power k is equal to cos k theta plus I sine k theta. So now the step 3, to test for n is equal to k plus 1. We start with our left-hand side, the cos theta plus I sine theta to the power of k plus 1. We want it to be equal to our right-hand side. That's what we need to prove down the end. So to do our manipulation, we use our indice laws to break it up. And then we use our assumption step. So power of k is going to be really large. So we use our assumption step, and we're able to put that in. Then we multiply it all out, and we get this line here. So that's just the expansion of the two brackets. And then we collect our real terms and our imaginary terms. So there's our real parts and our imaginary parts. Now if we have a look at our real part here, we can see that's the expansion of cos of k theta plus theta. And as we said, we might need to remember our rules for the trig expansions, and that was one of the ones. Go back to the previous page, you can see that. And then if you look at the imaginary part, that'd be the expansion of sine of k theta plus theta. We can factorize our thetas out, and we've got our result that we needed to find. So thus it's proved. And it's true for 0, it must be true for 1 and 2 and so on by induction. So using DeMoivres Theorem, we've seen some examples of this type of question. So the only problem with this one is that we've got to remember that to use DeMoivres Theorem, it must be in modulus argument form. This one here is not in modulus argument form. Modulus argument form has a plus between the plus I sine theta. This one's a minus, so it's not there. But remember, we can do some manipulations. We did some of these last week when we did the manipulation there of the theta for the negative there to get rid of it. When we had theta there, but considered something like the fourth quarter, where cos of theta and cos of minus theta are the same in the first and fourth quarters. So those two parts would be the same. That doesn't change sign. But sine of theta minus theta is the same as minus sine of theta. So we can make that manipulation. So well, minus sine theta is the same as positive sine of minus theta. Now we're in modulus argument form because that's positive. We can put our minus 4 in. Minus 4 times theta gives us 4 theta, and sine 4 theta as well. So we can do that manipulation to get it in modulus argument form, and that's what you need to do for 2. We need to have a look here and see that there is a lots of manipulation going on with this one here. Now, there's lots of playing around, so I won't go through it line by line. You just need to make sure you can play around with it to manipulate it. So this one's some factorization out, then because it's sine theta and I cos theta, but we want it back in form cos theta plus I sine theta. So there's lots of manipulation that you can go on with to get this happening. So you could even, it depends on how confident you are with all the ideas of I, you can go from that line to that line. If you can see that manipulation there, that minus I times cos theta, minus I cos theta, minus I times I, positive I, will give you positive sine theta. But once you've got it in that point, you've got it in modulus argument form. So you can apply DeMoivres Theorem for that part, and the minus I to the power of 7 just gets multiplied there. So, and then you can keep working through with it. So again, we can manipulate it to suit our needs in different ways. Again, this is one like part 1 where we go, okay, cos of theta is the same, but minus I sine theta. Well, we can start to manipulate that to have a look at, to get it in the form we need. So we're going to that form there, which we can start to manipulate. Okay, so when we do questions like this, we need to make sure we can manipulate what we need to find in terms of those angles. If we look at this next one, we've just got to make sure that if it's something's in modulus argument form, we can start to apply DeMoivres theorem and then get the correct angle that we need and the correct value. So if it's not in modulus argument form though, we have to make sure we get it into modulus argument form. That's doable to get down to that part, but would take a lot of working by binomial theorem. So modulus argument form reduces something that would take you a couple of pages maybe to a few lines. Okay, so make sure if you're going to putting something to a power, especially a large power, it's going to be able to be put into modulus argument form there.